right? Blockchain technologies will negatively affect hundreds of thousands of people. Now, if we look at some of the things that have already been done, such as WannaCry, WannaCry is a crypto locker, right? And one of the payment method to pay the ransom to the adversary was done in Bitcoin. And Bitcoin is a blockchain-based cryptocurrency. And you can kind of see the potential here that an online payment system, a decentralized payment system, has potential negative effects, right? And so to the interested people in the audience, there's this really great paper by Jules and others that looks at the potential of smart contracts doing negative things. And I think it's a really interesting read. So if we go to the Ethereum website, and Ethereum is a platform or is a decentralized platform where you can deploy code and have it being executed decentralized without the possibility of it being censored and it being permanently online. So on the right-hand side, I've got an artist's illustration of the Chinese social scoring system. And if we think about this, right, so what would happen if we combine this? An unstoppable application running on a decentralized platform and an Orwellian nightmare software. So it's kind of a really interesting question to ask what is possible with blockchain. Now, the thing is, are we opening Pandora's box when we're deploying these systems? So do we really know what's going to happen in the long run? Can we assure that all the things we're doing at the moment are not going to cause harm to society? Well, I first want to start with a little bit about like the history or just general what's happening at the moment. So we've got this massive hype about blockchain, and many of you will have heard about this. And at first I was thinking, well, I'll present some exchange rates and like these big bubbles on the valuation, but I think actually that this image is much better at conveying the current hype. So during the .com bubble in around the 2000s, there was a website, pets.com, which apparently sold for more than $1 million, right? So this is a virtual cat, a crypto kitty, as a collectible token on the Ethereum platform. And this particular cat was sold for 600 Ether, which is currently around 100,000 euros. So you're looking at this virtual cat being worth 100,000 euros. So you can kind of see the parallels here between the past and the current. And one of the problems that comes with this hype is that people that are in a position to make a decision about the adoption of future technology, generally decision makers, they're kind of like influenced by this hype. And they think, or in my opinion, many people think they need to adopt blockchain technology, not because of the technical merits that this technology actually has, but rather just because of the hype. So I want to first start off with some misconceptions about Bitcoin, because it kind of serves well to highlight some of the misconceptions about blockchain technologies in general. So the first thing that you often hear is that users are anonymous. And while this may be true for some cryptocurrencies such as Monero or Zcash, in general, it's actually quite transparent what's going on. So you can actually look at all the transactions that are being performed in the network by all participants, and you can do transaction flow analysis and whatever. So there's actually very little anonymity with most cryptocurrencies or blockchain technologies. Another misconception that we often see is that every participant has to mine. So I guess this comes from a little bit from the explanation of how cryptocurrencies work. So you hear, well, there's this magic mining process and everyone's participating in consensus to reach agreement. And while this was true in the beginning for Bitcoin and similar systems, most of the time mining is actually done by professional mining pools, by professional entities, and it's far from being as decentralized as everyone thinks it is. Another thing that I've seen, in particular in the German-speaking, so I've seen this on blogs also and talks, that it's claimed that the blockchain is encrypted, so your user data is encrypted. And this is not true for most blockchain constructions. So everything is transparent, and instead it's actually digital signatures that are used to just verify that you're allowed to actually perform a transaction in the system. Another thing that is often misunderstood is transaction finality or general consensus finality in most blockchain systems. So what this means is if you are performing a transaction, it's not instantly confirmed, but rather miners start mining and it's included in a block. But even this inclusion doesn't mean that your transaction is going to stay that way. So the way this consensus mechanism works is that the probability of your transaction staying the way it is increases exponentially with the number of blocks being mined. But this still means that your transaction can fall out of or can change in its order or even become invalid if the state of the blockchain changes due to a fork. And finally, I think this is one of the most important misconceptions. It's always claimed, or it's often claimed, that no trust is required, or this is some trustless design. And that's actually not true. In Bitcoin, or in most cryptocurrency systems, your assumption is that the majority of participants, or the majority of consensus participants, is honest. So rather than extending trust to a single entity or a small select set of entities, you're now trusting that the majority of them are behaving honestly. But this is just one aspect of trust. You can also look at other elements, such as the client that you're downloading and the software that you're executing on your node. And generally speaking, when you're downloading like a wallet software on your mobile phone, for instance, you should actually verify that this software was correctly implemented. And I doubt that many users actually do this, so that they fully check and see if that works out. So there's all these different elements of trust that still go into blockchain systems. So I think deriving from these common misconceptions, you have this general idea that, well, if Bitcoin's so successful and if these cryptocurrencies are successful and suddenly you get all this new valuation and this hype, and they're based on blockchain, well, then blockchain must be good for my application as well. It just has to be good, right? So, of course, this is a fallacy. And the problem is that because of this, I think a lot of these misconceptions flow into this assumption that blockchain is going to be a good use case for something without actually fully understanding what this technology can offer, what this technology is capable of offering for me. So let's first try and define what we actually mean by blockchain. And this is interesting because in January next year, Bitcoin will have its 10th year anniversary, but we still don't have an agreed upon definition of what we actually mean by blockchain. And interestingly enough, in the original white paper, in Satoshi's white paper, the term blockchain is actually never mentioned. So this is something that's kind of evolved because of the data structure of Bitcoin, and it's been a community term that's just been used more and more. So the first definition is from a recent position paper by NIST, so National Institute of Standards and Technology, and they just call it the actual ledger. And to be fair, this position paper is actually quite more involved and it goes into a lot of details. But the idea was to be as inclusive as possible to actually capture all these different systems that are currently out there that are being sold or being advertised as blockchain, because you've got all these different designs, and if you're very specific, well, you leave out half of the ecosystem. The second definition comes from the Princeton Bitcoin book by Narayanan and others. And it's very data-centric definition. So it says it's a linked list with hash pointers instead of pointers. So you've got this authenticated data structure that kind of defines what we call a blockchain. And this is interesting, but it's kind of missing this whole consensus element. So who's allowed to actually write to the system? How do we agree upon the head of this hash chain to make sure that we all have the same hash chain? And the final point I have here is what's called Nakamoto consensus. And basically, the scientific community has come in and has tried to formally specify what kind of guarantees protocols such as Bitcoin or Ethereum, like the underlying construction, what guarantees you can derive in different system models. And this is still ongoing work. This is research that's currently happening. And we're trying to define what we actually mean by blockchain. But we haven't really found a nice conclusion or a definite answer for this. So if you look at these definitions, they're so vague. Well, what about Git, right? So Git has an authenticated data structure because it's got hash pointers. You have potentially multiple readers and writers. So by some of these previous definitions, Git is actually a blockchain, or your Git repository is a blockchain. So you can see that it's kind of sometimes nonsensical to make your definition too wide because, well, then everything and nothing is a blockchain. So I don't have an answer to this question of what we should define as being a blockchain, but for this talk, I'll just stick to this simple definition that a blockchain is a distributed ledger based on authenticated data structure. So we've got some kind of authenticated data structure, and it's in this distributed context, so it's not just one single entity that has this. So many of you will probably have seen this. The thing is, a blockchain or blockchain technologies don't make a lot of sense for many use cases. So we can just say, well, you don't need a blockchain, let's go home, let's just call this a day, we're done, right? Unfortunately, it's not quite that simple. There's a really nice publication by Wüst and Gervais called Do You Need a Blockchain? There's a link for this. And they've got a nice flowchart, and it basically helps you with the decision, would a blockchain or would a blockchain technology make sense for a particular use case? Now, I don't want to go into all these decision points, but rather just focus on the types of blockchain that they've listed. So at the top right-hand corner, we have what's called permissionless blockchains. And this is basically what Bitcoin or Ethereum or similar decentralized cryptocurrency is. And in this system model, you don't necessarily know all participants, in particular all consensus participants, and they can come and go at any time. So for this system model, actually proof of work is the most well-known and established way of actually achieving this. And this is the innovation behind Bitcoin, to be able to work in this peer-to-peer environment. However, there's other alternatives on the horizon, such as proof of stake or other proof of space constructions, whatever, but they're still not as established and well-researched as proof of work. So for this particular system model, proof of work makes sense. A little bit below, we have this construction which are generally termed permissioned blockchains. And the idea here is that not everyone is allowed to interact with this blockchain construction. So in a public permissioned blockchain, generally what's meant is that everyone can read from this blockchain. So you can download a client and look at the entire ledger, but only a select few participants are allowed to make updates. So the consensus nodes are the ones that are authenticated, and they are the ones allowed to make changes to the system. On the other hand, a private permissioned blockchain is one where even just reading the blockchain, you need permission. So you need some sort of key to be able to do this. And this kind of construction makes the most sense for consortiums, for companies maybe as an internal thing. And here the focus is probably mostly on the authenticated data structure rather than this consensus mechanism. And finally, you can come to the conclusion that a blockchain or blockchain technologies won't make sense for any use cases you have. And I think in this context, more people should be confident to just say, well, I've looked at all the options, and it doesn't make sense to use a blockchain, so I'm not using a blockchain. Why should I? Because it doesn't make sense. And I think if more people do this, maybe it will help also to push forward the sensible use cases. And finally, you can always still accept cryptocurrencies as a payment if you really want to show your enthusiasm, even if you're not using it. So you come to the conclusion you need a blockchain, or maybe you've already got some blockchain system implemented. Well, what could possibly go wrong? And the answer is everything. So the thing is, most of these technologies are still kind of being developed as we speak, and I don't think it's a good idea to just like pull code from a Git repository, compile it, it compiled, awesome, my blockchain's finished, and I'm using it. So what you have is these systems are actually evolving and changing during their lifetime. And I'm not sure that this makes a lot of sense if you want to productively use a blockchain. Say you want to store identities, right? So you've got an identity system. I don't think it's a good idea to be changing your consensus mechanism in between having this identity system that's, for instance, being used to register passports. That's probably not a good idea to do. So I'm gonna outline some things that can go wrong, or design decisions that are kind of not really sensible. And I specifically chose not to name projects that do these mistakes, or mistakes in my opinion, but I'm pretty sure if you just look around, you'll find real-world examples where this has been done wrong. So let's start with the first thing that you can do wrong, and this is using proof of work. So proof of work only ever really makes sense in this decentralized construction, and only really makes sense if your computational power is extremely large of this whole system. So the security assumption, like I said, is that 50% of or more than 50% of the participants or the computational power is honest. Now, if you're running 5 nodes with like some VPS or whatever, and they're using their CPUs to do proof of work, if one of them gets compromised and they just rent cloud hashing power, they can completely dominate this network, and it just doesn't make any sense. So it's kind of nonsensical to use proof of work in this context. Also, so basically, for most use cases, you'll probably find just using a consensus protocol. And there's Byzantine fault-tolerant consensus protocols that have been there for over 20 years. They've been looked at, researched, and so you can kind of call them more or less stable. But you should also not try to implement your own consensus in the idea, well, this is all crap, I'm just going to do my own thing. Because chances are you'll get it wrong. And if consensus fails, your whole ledger is basically broken because there's no agreement on what's in there. So the next thing, I'm amazed that I even need this slide, right? Everyone should know that you don't roll your own crypto, right? And it's really hard to get cryptography right. And it's not just like you should never design your own crypto algorithms. You should not implement your own crypto libraries unless you really, really, really know what you're doing. And this is still being done, unfortunately. And in particular, we see also this aspect where a lot of really not well-tested cryptography is being used. And I kind of doubt that projects that don't really have a cryptographer on board but still claim that they're using non-interactive zero-knowledge proofs in some elaborate scheme, that this is going to be safe. So I think there's a lot of potential for things going wrong if you don't really fully understand what you're doing here. Another thing, and I guess this is true for almost anything, is to try and avoid making things too complex. So you have this really simple use case, and instead of implementing the simple use case, instead you add on all these additional things. And I think this may in part be a reason, or the ICO hype may be a reason for this to happen. So you've got this pressure to try and make the next biggest thing that solves all the problems of humanity. And this is not a good idea because the complex interactions will most likely to problems down the road. Another thing, in particular coming from the blockchain space, is cryptoeconomics, so this idea to use cryptoeconomics. So what is cryptoeconomics? It's this concept of using game theoretic incentives in combination with protocols to try and steer the behavior in a way that the protocol does something nice. And this is what Bitcoin does. So you're incentivized by the value of the coins to kind of behave honestly as a miner. But there's a lot of things that can go wrong, and while this is a highly interesting research topic, like deploying a blockchain with this game theoretic incentives where you're not sure what they're going to do is a problem, because maybe your incentives are misaligned and you're actually incentivizing users to do bad things or things that are problematic. So I think it's a good idea to try and get rid of crypto economics or incentives as much as possible. And finally, privacy is really hard to get right. And in particular, if you think about blockchains as authenticated data structures where you potentially can't make any changes, well, anything that you write in there is going to stay there for a long time. And it's like your obligation as a developer, but also as just in general, to try and minimize this exposure of users as much as possible. So I think it's really important to think hard about this and only save the absolute minimum, or use the absolute minimum of data that you can possibly do. So I've now pointed out all these things that can go wrong and which are problematic. And you'll probably say, well, this doesn't look good, right? We're kind of stuck here. Is blockchain even making sense? Should we just go away and give up? And what I'm actually trying to do here is point out how difficult it is to do engineering right and do it properly. And I think we as computer scientists need to really carefully look at these constructions and make educated decisions, well-informed decisions to try and get this right. So with this, I want to kind of come back to my beginning. So spacefaring technology and rocket technology has caused a lot of harm to humanity. But at the same time, we are able to bring people to the moon, people to space, put satellites into orbit, and allow a lot of really interesting technologies that make our modern day lives possible. And I think some of the applications of blockchain technology bear that same potential. But we just need to put a lot of engineering effort into this to get it right and to make sure that we actually do have a net positive outcome for everyone. So thanks.